Hello everyone. So who wants some flag for the CTF? Oh, I see nobody. Okay. Well, so I will talk about app layer plugins then. Yeah. So first words of introduction. I am Philippe Antoine. Philippe. You can also know my GitHub handle Catena Cyber, which is the name of my French company. And I have been a part-time SuriCata developer for 5 years now. I love open source, network traffic analysis, cybersecurity, and fuzzing. If someone wants to talk about fuzzing, or about SuriCata or other projects, I would love that. And yeah, so I have been fuzzing SuriCata, but also developing, doing development on the app layer parsers like HTTP2. And recently I have stuff to improve the rule language like bidirectional rules and absent keywords open pull requests if you're interested in looking at them. And so without further ado, I will begin by doing the demonstration of what an app layer plugin does. I will look this way. So let me just remove the logging that was there, and then run SuriCata. We see some logging, and then we can see that we have a log file with some event types that you should not be familiar with, like event type Zabbix, with some Zabbix metadata, and we then also get some alerts with Zabbix frame and Zabbix metadata, and yeah, goes on with some other stuff. Yeah, coming back to this, describing a bit more what is going on. So I just launched SuriCata with some configuration, which I named Zabbix.yaml, with some rule set that I call Zabbix.rule. Yeah, always disable the checksum and single run mode to be more possible. And logging, and I use a pcap that I found in NDPI GitHub repository. Thanks for that, Luca, if you're here. So let's show the pcap on Wireshark. So Wireshark can also decode Zabbix. We can see it here, and yeah, we see the same data that, for instance, this is the old Zabbix version doing a request for proc.num. So yeah, the pcap is there. We saw that we managed to extract something. So we used the Zabbix.yaml configuration. So it's basically a default configuration, with the main change being here that I have added one plugin with the full path to my dynamic library, which does the Zabbix plugin, which is pure Rust, as you can see the target debug. And I also have in the output section Zabbix enabled, so that I can have Zabbix event, and in the app layer protocol section Zabbix enabled, so that I can do the protocol recognition and then parsing. But otherwise, that's pretty much the standard SuriCata.yaml configuration. And the Zabbix rule. So alert Zabbix. We can use Zabbix as a player protocol. 3 rules, as you can see the 3 lines. So first rule is with a frame, which name is zabbix.data, and not much else beyond that. Second rule is new keyword, zabbix.data, which is a sticky buffer, so with content proc after that. And the last rule is zabbix.flags, another keyword which is not about content buffer, but is integer. So we check that as a bit flag, the first bit is set. We do not care about the other ones. This is just for testing. These are not real meaningful rules to detect attacks. Maybe there are some in some challenge. Yes, so I guess that was it for the demonstration. So yeah, we can also see the SuriCata logging, that there is some going back and forth between C and Rust and SuriCata and the plugin to do the initialization, the registration, and yeah, then in the end we get the result we want. So if you're interested in the code, you can use this plugin. I have put it in a repo, so you can go there while I talk about it. And currently, it's not completely merged in SuriCata what is needed to do this. So it's the pull request 12.1.1.8. Which still does a bit of stuff before the final commit, which introduces the plugin, which is not that big, but there was still some work to do, as I will highlight a bit later. That's not the that's the last pull request of a series of pull requests. So maybe a few words about Zabbix, because I suppose not everyone is familiar with it. So Zabbix is from Wikipedia, open source software tool to monitor IT infrastructure, such as networks, servers, virtual machines, and cloud services. This description sounds familiar, like SuriCata is an open source software tool to monitor IT infrastructure, such as networks, servers, etc., etc. But the difference is that Zabbix is not analyzing network traffic. Zabbix collects and displays metrics from different sources, like CPU usage, memory usage, or number of process running on a device, etc., etc. So it's an open source. You can go see their source code. They have a self-hosted Git. And they also run a bug bounty program with C software. I guess that's how I first met the project. And unlike SuriCata, this repository is there are libraries, and there are different processes which are meant to be run on different devices, like server, agent, proxy, and a few different roles. And so these different processes communicate to one another, and that's why they invented a Zabbix protocol, which is documented and which is quite simple. So that's why I also picked that for the demonstration. So yeah, the protocol header definition fits easily on one slide. There is one magic, ZBXD, so quite easy to detect with pattern matching. useful for us, and also useful because if I am correct, the different processes talking to each other talk on different ports, so maybe not so predictable. Then there is a byte for bit flags to say if there will be a compression, a large PDU, or just if it's Zabbix protocol, and then the data length of the PDU with some field which is reserved, or the length of the incompressed data, and then the data. So the data, depending on the processes, is now in version 7 some JSON blob with different keys and values, and in older versions like the one in the pickup, it was like text-based with requests and answers with no obvious formats. But yeah, so quite easy. Python line to do Zabbix client is, yeah, Python script to do a Zabbix client is like one line described here. So yeah, I took this protocol, but the point with AppLayer plugins is that you can do whatever you want then. And I did it in pure Rust. So that was kind of a challenge, but taking the hard path to have more benefits in the long run. So the first important thing to be able to have a Rust plugin with whatever other program, I guess, is that you should use this Rust flag that says that, yeah, I compile this, but at link time I will find some functions that are not defined because they are in the main program. So my plugin will use some functions that are in Suricata, and so Rust by default is not happy about it because, yeah, it's incomplete. One thing that I did not implement yet, but that I foresee for plugin support, is to use Rust so-called features. So they are a bit like if-def in C, so that the plugin can be compatible with different major Suricata versions, because in different Suricata versions we will have API changes for some functions. So that's a way to achieve compatibility. And yeah, I already showed you the YAML configuration. One thing that I did not show you yet about this, so this is the repository of the plugin. So I use Golden Test to develop. I guess it's quite performance when developing a AppLayer parser. So I just run this bash script that just compiles, check that there is no warnings, and then I have pickups, and I just read them all and just have the output in my Git. So then I can do a Git diff to see when I add new features or fix bugs if it changes the behavior, and I remove the flow ID so that it's fully reproducible. Yeah, and so basically the source part of the plugin is, as in the below part, the traditional files that you would find in Suricata source tree for AppLayer. So lib.rs or mod.rs is just the list of files. There is AppLayer name.rust with the entry point logic, I would say. There is parsing, logging, and detection. So I did the same for the the plugin, and then there is some glue code that is specific to the plugin. So the plugin.rust is quite simple. It contains the entry point of the plugin, which is SC plugin register, which will be called by SuriCata after dynamically loading the dynamic library. There is this function. And so, yeah, if you think about supply chain attack, your plugin will run the code that you want, so you should not run untrusted plugins, because here I do the right thing, but yeah, I could do whatever here. So this returns a structure which is named SC plugin with one callback, which here the value is named Zabbix plugin init, which does another such round with all that we need. So there is some naming, a function to register the app layer parser, a function to do the logging, and functions to register the keywords. So, yeah, that's what I just said with the slide. And then we have SuriCata.rust. So I did a pure Rust plugin, so it's self-contained. And so in my way of thinking, I can continue to talk even a bit without the slide, but should I do anything? Oh, coming back. So SuriCata.rust is for me like the header-only definitions that are in SuriCata needed by the plugin. Yeah, just. So for instance, we need to know that the structure Rust parser that we will register have 20 fields, and the first field is this kind of callback. So functions with their arguments and their types. So types definition, like a structure definition. And some values like, we will return ILPOTO unknown if we do not have enough data at some point, or stream to server. So we have to have the same definition between the plugin and SuriCata. I have not been using SuriCata derived magic. I have not been using anything SuriCata direct SuriCata code into a crate. So maybe that's a further improvement to have something more Rust idiomatic. But yeah, I did not see it yet. And also one other thing to note: even if we did a pure Rust plugin, we still have to resort to the C-like API, even for code such as JSON Builder, which is done in Rust and can be called from C. But we do not know which Rust version we used to compile SuriCata and the plugin, so we do not know if they are compatible. So we resort to the lingua franca, which is the C and the way to pass arguments to them. So yeah, there are also a few other limitations today. So the logging, it's just simple logging. You cannot take arguments like configuration arguments yet. There is some planned work on that from Giuseppe. We're taking some work from Sasha on that, thanks. There is also a limitation on the keywords. We cannot yet use validation callbacks, but I guess that will come soon. And another limitation that we cannot do yet in the plugin is if we want to have keywords matching on multiple protocols, like J4 being both TLS and quick, or seeing Kerberos in LDAP or that kind of stuff that is not yet supported, that supports like simple stuff. And as I said, it was a long coming work. So started with an old pull request number by a big number of cleanups and fixing the script that we have to set up an app layer if you want to add an app layer in Rust code. And that's kind of the hard path doing this for Rust and self-contained, but that's, in my view, that was to make things more generic for SuriCata and easier, remove some boilerplate code that was in logging and finding bugs along the way. That by making things more generic, we realized that there were not all protocols that were adding their app layer metadata for alerts. And by the way, there is still a DHCP missing because it's using some configuration in a weird way. I did not dig too much into that, but it's still to be fixed. And so move the many output files from C to pure Rust because I wanted to be able to do that as the plugin. So let's do that for the SuriCata protocols that are there already. So raising the percentage of Rust code as well, and also make the number of keywords dynamic because it was first fixed in a static array at compilation. So now we realloc and try to add more, and they can be pure Rust, and also along the way we can fix some bugs about integers being used or logging using a dash instead of underscore, etc. Transforms can also be done in Rust and so can also be used in plugins. That's the most recent work that was merged. And the last pull request, besides adding plugin, the last step before that was to make the number of app layer protocols dynamic, and this was the most painful part because there were a lot of arrays using the compile time constant alproto max. So when I first started 18 months ago, I just cheated and I did some configure time options to increase alproto, and then I could just register one or two plugins. So I guess I have a bit of time to use to show it. Oh, no, yes. To highlight up. So this is the open pull request for now. So this was, is there a date? April 26, 23, which started, so long ago. It started with doing that kind of simplification, just we use the function that is already stringing the alproto instead of recoding it, so that we do not need to patch this file when adding a player. And so moving code from C to Rust with also the objective of becoming a negative line of code's contributor to SuriCata, which is the case until we merge the libhtp in Rust, which will explode my counter again. So So yeah, basically we were just removing all these C and header files, or not all, but many of them, and just used what was in Rust. So, yeah, conclusion. So, yeah, we Rustify all the code. Thanks, Giuseppe, for following me for already Rustifying the SIP keywords. So, I'm not the only one doing that. And yeah, please do write and share your plugins to extend SuriCata's capabilities. So you do not have to pass Victor's approval. You can publish them on GitHub, even if they do not get merged in SuriCata in the end. Yeah, it's still ongoing. So there are like, I would say like 5 or 6 protocols where we moved all the keywords to Rust, but there are like 5 or 6 more to do. To improve the Rust percent of code, and yeah, future work to improve the generic logging with options, so that every protocol can enjoy it, plugin or not. Maybe have something smarter or more Rust idiomatic for create, so that my plugin doesn't have to redefine what is in SuriCata, but even if it does not need to compile SuriCata and its 200 dependencies, I mean, there is like just num in my Zabbix plugin, and maybe I could have done also without it, because the protocol is really simple. Oh, and there is the decompression stuff still. And yeah, and the work to have maybe something generic and not hard-coded for having keywords which may exist over different protocol, I can also add. So, thank you. Do you have questions about the presentation? Or
Thank you for the presentation, and many thanks for the provided works. And the question is that how the mentioned SuriCata.rs module is maintained. As I understand, it contains some definitions and functions and some common stuff from SuriCata root modules like CoreRS and things like that. And how it is created and how it is maintained.
So yeah, basically I maintain it by hand and running my golden test, and when someone updates some function or prototype to add like detection context argument to this kind of callback, then I get seg fault and I say yeah, and I just look at the log and I say yeah, I need to add this to my function prototype. So now it's not well done, it's done by hand, and it's supposed to match the latest master version, but maybe there is something smarter to do with SuriCata header crate that defines, but yeah,
ideally such kind of common file must be somehow automatically generated from corresponding main SuriCata files, but well, I don't know.
Yeah, and I guess that also in my plugins I use functions from. We can take a look. So first, there are many types. And yeah, here are the functions. So there are some functions that may live in C code, some functions that may live in Rust code, like the JSON builder stuff, even if they have some unsafe extern C API around them. And so yeah, I guess we should use something like bindgen, which is like C bindgen, the reverse way that generates something out of C for us to be used, but I did not try that, so I guess...
Okay, thanks a lot. I believe we can discuss it later, and since it's very technical details. Okay, thank you.
Hi, hello, thank you. A couple of questions. Did you measure any performance penalty by moving on the plugin?
I did not do any performance measurements, and as you could see, I just have a toy pickup with just to show the impacts. But I do not think that it should change much. Besides, yeah, we have a new protocol, so maybe I've been dumb and I've made my implementation not efficient, but it should be. It should not change much the performance of overall Suricata.
Thank you. And the other one is, as the OISF, you are going to have at least a set of vetted plugin that you trust, plugin that you maintain.
We have not discussed about that, so no. For now, this is not fully merged into Suricata, and I guess that, in my view, my personal view, this was like something open, so that anyone can put his plugin, and maybe my plugin is bad, and if I fuzz it, there is some way to make it panic easily. But yeah, I did something for Zabbix if you want to have Zabbix. So, and maybe you can, if you find a bug in it, you can fix it, and we can go on like that. So that's how I imagine it, not having something like vetted, approved by OISF.
Thank you.
Philippe? So thank you a lot for the plugin API work. I know it is a lot of work making the things dynamic and so on. So again, thank you. More proposal for discussion than a real question. But do you know that you use dylib API for Rust? Do you know it is unstable and it can cause problems?
I use what for Rust?
The dylib target compilation. You are doing kind of dynamic plugins in Rust which are not well supported. I can explain you technically why.
Okay, I did not know that it was unstable.
It is, unfortunately. And well, I can talk especially of something which is called the diamond dependency problem, which will happen anyway in the plugins. So, and since most of the things, in fact, you're using is C, it might not be that difficult to use the C dynamic plugins from Rust and still be able to do everything you used. So with minor changes, maybe it will be stable and without problems.
Okay.
So let's discuss that later, but thanks again.
Thank you, Pierre.
One question. Yeah, in terms of security for loading those plugins, how can we make sure that there is someone not creating any malicious plugin, loading it in SuriCata and doing some stuff?
So either you write the plugin yourself and you trust them. No, but you should just, I guess, read the code and see that it does not do something crazy. But yeah.
But if you give the API open, so anyone can write his own plugin,
and I do not even need the API. As soon as the Suricata calls my plugin, I execute code and I can do. Yeah, if you have some binary plugin only, you have to be very faithful.